So in the previous classes, we were talking about different methods that we are using for simplifying solving any electric circuit. And so far, we have learned how to use node voltage method for solving any problem, and how to use mesh method for solving also any problem. And we studied before those KCL and KVL, and we hear about two different identities, the current divider and the voltage divider. And also we know the very simple law for Ohm's law, which is R total is equal to V over I, or V is equal to I times R total. If you still remember, I told you that I could use KCL and KVL for solving any problem. For Ohm's law, to find R total, I'm not allowed to do that unless I have a voltage source, which is one source, and at that time I will try to find R total seen by that source. But again, simplify for finding the total resistance for a specific branch or for a specific portion of the circuit. And then we started talking about current divider and voltage divider, and I told you that these two identities, I could use them as like steps for simplifying solving the circuit, but probably I will need one general method like KCL and KVL to help me. Maybe the current divider will help me for simplifying part of the problem for calculating the current in a certain branch, or the voltage divider could help me for finding the voltage for a specific branch as well. When we started talking about different methods like node voltage method, I told you that this method could be used for solving any problem. So any problem you would like to solve it for finding the voltage for the current, you can use node voltage method. And by the same way, I can use mesh method for solving any problem. Today, I'm going to introduce a new method, which is called source transformation, or source conversion, or source substitution. Actually, this method is used for simplifying the circuit. If I have a certain circuit that has many voltage sources, many current sources, and I would like to simplify that circuit, I can use source transformation. But if I'm asking you to find the current across a specific branch, and this branch is part of the voltage source for the current source that you will convert it, please try to avoid converting that part. I'll show you example related to that. So source transformation, or source conversion, or source substitution is saying what? It is saying any voltage source. What is the meaning of voltage source? The voltage source is voltage connected in series with resistor. This is the voltage source. This method said any voltage source, which is voltage connected in series with a specific resistor, could be converted to a current source. What is the current source? A current connected in parallel with a resistor. So any something like that, which is voltage source, could be converted to a current source. What is the voltage source? Voltage connected in series with resistor. What is the current source? Current connected in parallel with a resistor. So if I would like to convert this guy, which is the voltage source, to a current source, what should I do? I will try to draw current connected in parallel with a resistor. What is the value of that resistor? It is the same like the resistor connected in series with the voltage source. What is the value of this current? This current I is equal to the voltage source value divided by the resistance. And he said vice versa, which means if I have current source and I'm looking to convert it to a voltage source, I have current source connected in parallel with the resistor, and I would like to convert it to voltage connected in series. I will draw this guy, which is voltage connected in series. What is the value of the resistance? It is similar to the resistance connected in parallel with the currents. What is the value of the voltage? The voltage is equal to I times R. So if I have voltage source and I would like to convert it to current source or vice versa, I can do that. This is very simple thing. Let us see problem related to that. Solve the following circuit to calculate the current R. Circuit like this one, I have 5 volts, I have 2 ohms, I have 7.5 amperes, and I have 2 ohms. I would like to solve this circuit. Which method could I use? I could use different methods. Can I use mesh? Can I use mesh voltage method? Yes. How many loops do I have? But do I need those two, or I can use only one? Can I use one? Yes, I will use this guy as a super mesh. Am I right? So I can use this guy as a super mesh, and I will say summation the voltage for this super mesh is equal to 0. At that time, I will assume the current in this mesh is I1, and the current in this mesh is I2, and the current in this guy is I1 minus I2, based on the direction. And then I'll say summation the current for the super mesh is equal to 0. And then solve for finding I1 and I2 by using two equations. The equation for the super mesh and the current in this branch is the difference between I2 and I1. I1 is equal to, I1 minus I2 is equal to 7.5. At that time, I have two equations and two unknowns, I can solve them. So I can solve this method if I want by using super mesh. It's very easy. What about if I would like to use node voltage method? Can I? Yes, you are assuming that this guy is your reference node. And how many nodes left? I will say for that node summation, I is equal to 0, and I'm going to assume that the voltage for that node is unknown, which is, for example, V. And then I'll say summation the voltage for that node is equal to 0. I'll have only one equation and one unknown. Solve that problem, find V. After finding V, I can find this current, because this current is equal to this voltage minus V divided by 2. Can I use the current divider? The answer is no. Why? Because I don't have two parallel resistors. Can I use the voltage divider? I couldn't, because I'm not seeing any two series resistors to use the voltage divider. Can I find R total? It's hard because I have two different sources. So R total refers to which source? So based on our discussion, I can solve this problem by using different methods. Also, I can solve this problem by converting the voltage source to current source or vice versa. Let us solve this problem by using two different methods and see if the solution is different or it is the same. Let us start solving this problem by using first node voltage method. So if I used node voltage methods, what I have to do is, I will say, this guy will represent my reference nodes. And this guy is representing V1, right? Which is the unknown voltage, but I would like to copy that because I'm going to use it later on. So I would like to copy this circuit first. So what am I going to say? This guy will be my reference. Then this is V1. I will say summation I is equal to 0 for node 1. This current plus this current plus this current is equal to 0, which means V1 minus 5 over 2 plus V1 minus 0 over 2 plus 7.5 is equal to 0. Any question for that? Now, I'd like to solve that equation for finding V1. So I can say V1 over 2 and V1 over 2, I'll keep them together. So I have V1 over 2 plus V1 over 2 minus 5 over 2 plus 7.5 is equal to 0. Based on that, I can say 2V1 over 2, which is V1. And I have here negative 5 over 2. It is 2.5 with negative sign plus 7.5. It will be 5 with positive sign. Based on that, I can say V1 is equal to negative 5 volts. If V1 is equal to negative 5 volts, I can find I. I is from this point to that point. The voltage for that point is 5, and the voltage for that point is negative 5. So I can say the current I is equal to 5 negative 5 divided by 2 is equal to 10 divided by 2, which is 5 amps. Any question for that problem? Okay, so I have already calculated I. It is equal to 5 amps. If I asked you to repeat solving the problem, and I'll leave that to you by using mesh voltage method, you should have I equals 5. I'll leave that to you as an exercise for yourself. But I'm not asking you to solve it and submit it on practice space. This is for you. Try to solve this problem using mesh current method. And if you got I is equal to 5, that's good. If not, please come and ask me and I'll show you how to find it. Maybe you did a mistake. So let us repeat solving this problem using the new methods that we have already learned in few 5 minutes ago, which is source transformation. So you would like to find, let me put this circuit again, and then another method. If I would like to use source conversion, my question right now to myself, which source should I convert it? Should I convert the voltage source to current source or the current source to voltage source, and why? Why current source to voltage source? Yeah, but not only that, because I asked you to calculate the current here. So if you try to convert this guy to current source, you are changing the configuration of the circuit, and probably you will get lost. Are you seeing what I'm talking about, guys? So I will avoid changing this guy. Why? Because I don't like to get lost. I'm changing the configuration of the circuit, and you are asking me about the current in that branch. Where is that branch? Probably I will forget while I'm writing the final exam or the midterm. That's why I prefer to avoid converting this guy. I will convert this guy because I asked you to calculate the current for this one. So if you try to convert this guy to this guy, I will try to convert it to voltage source. My friend is saying by converting this guy to a voltage source, we will have only one loop and it will be very easy to calculate the current. If you try to do that, what you will have? You will have this resistance, which is 2, And this guy, which is 5 volts, it doesn't change. And this guy is still I. And then you will have this guy, which is, this is voltage source. What's its value? V here is equal to what? I times R. What is I? It is 7.5. And what is R? It is 2. So this guy is equal to 7.5 multiplied by 2 volts. And I have this resistor. This guy is 2. Now, I have this voltage source. It became 15. Now, what do you want? I would like to calculate I. How many sources do we have? I have 2. They are in the same direction or different direction. So I will add them or subtract them. I will add them, so I can say I is equal to V total, which is 5 plus 15, divided by the total resistance. Can I find the total resistance? Yes, they are connected in series, so the total resistance will be 2 plus 2. If you try to calculate that, this will be equal to 20 over 4, which is 5 amps. I'm right. I got the same answer, which means this is the right way for solving such a problem. So you can use whichever method you like. You can use mesh method, node voltage methods, source transformation or conversion, KCL and KVL, whichever you like, but at the end, you have to get the right answer. So if you try to look to this circuit, this is very, very simple circuit. It has only one current source. Am I going to give you something like that for the final exam? Maybe, but there should be like more than one source. We can convert 2 sources till we reach to the required circuit. But what I would like to mention here, you have to pay your attention while we are converting from voltage source to current source and vice versa. Here, this is the direction of the current. That's why I put here negative, positive. It's following that direction. I put here, if you try to look here, if I have negative, positive, I put the direction of the current upward. So I'm following what I have. And probably this is your question, right? That's why I asked you wait. So this guy is downward. If you try to look to this conversion, this is negative, positive. And I'm following that direction from negative to positive. I'm trying to mimic what I have by making conversion. One more thing I would like to let you know. If you are dealing with that conversion, you have to know if I connected 2 sources, voltage sources in parallel, like imagine, for example, I have something like that. What is the voltage value between those if this guy is V? The voltage value between those, if this guy is V and this guy is something else, should I add the 2 voltage or the voltage should be the same? Since you are talking about parallel, it means if this guy is V, this guy should be V. And the total voltage between those will be V. So why we are talking about parallel voltage sources? Since the total voltage doesn't change, why we are connecting them in parallel? Any question? Any answer for that? Yes. Because I'm increasing the generated power by increasing the current, not increasing the voltage. Because if you try to look to the generated current here, imagine that this guy is I. I is the summation of I1 and I2. But if I have only one voltage source, I'm expecting only one I. So I is equal to I1 and I2. I'm expecting two different currents here. If those two patterns are identical, I'm expecting I1 and I1. If those two patterns are identical, I'm expecting I1 and I1, which means I'm doubling the currents coming from these two patterns. If you are doubling the current, what's going to happen? The power will be doubled because P is equal to V times I. So connecting two voltage source in parallel means you are increasing the generated current. But what about the voltage? It's constant. And by the same way, connecting two series, something like that. This guy, if it is I, so this guy should be I. It shouldn't be different. But why I'm connecting them in series? Because I would like to increase the generated voltage. So I have voltage across this guy and across this guy. What about if I have something like that? This guy, if it is V, this guy should be V. It could be anything. It doesn't matter. Because each one will have a specific voltage, but they have the same current. But what about if I have, for example, two currents like that? Two current sources. If this guy is I, this guy should be I? No, it doesn't matter for two current sources connected in parallel, because at the end, the total current here will be equal to the summation. So I have to pay my attention. If I have two parallel current sources, the total current may be the summation, may be the difference, based on the direction. So if this guy is downward, so this guy will be I1 minus I2. If I have two parallel voltage sources, the voltage should be the same. You have to pay your attention to these simple things. Any question? Yes.
And the other is V2, like 9 volts and 12 volts. What
I couldn't connect two sources in parallel unless we have the same voltage, and we are calling this in power systems synchronization, which means I'm connecting synchronous generator in synchronous with the grid. This synchronous generator should have the same voltage like the grid. Unless if you connected two different sources, like for example, imagine you are talking about the first example that I covered here, when I told you if you have a dead battery, a live battery, and I connected them, so one is going to feed the other one. And this could happen in the real life while I'm connecting generator in synchronous with the grid. If the voltage of the synchronous generator is not equal to the voltage of the grid, the synchronous generator voltage will try to be increased or decreased based on the grid voltage. But at the end, after a few seconds, they should be the same. Okay? Now, let us talk about new different theory. I have already posted new notes, which is talking about these different methods, Thevenin and Norton, maximum power, and superposition. But I don't have time to talk about Thevenin and Norton and maximum power. I prefer to talk about Thevenin, Norton, and maximum power next class on Friday, because I need more than one class to cover that. So I'll talk today about superposition, which is very simple theory. So let us talk about superposition, which is method number 4. Superposition. What is written in your textbook is what am I going to write right now. He is saying a linear circuit excited by multiple sources will have a response which is the sum of individual responses. Let us see example to clarify that. Find VO using superposition. Superposition. This is the circuit that I have. This guy is 3 amps. This guy is 8 ohms. This guy is 4 ohms. This guy is VO. This guy is 20 ohms. This is 5 ohms. This guy is 25 volts. And I would like to solve this circuit using superposition for calculating what we are calling the voltage across 8 ohms. Before I start solving the problem, I'd like to talk more about the meaning of superposition theory. How to use it. So before I start talking about that method, I'll give you a very simple example. Imagine we have 3 different sources of water. And I have a certain tank. And I would like to open these 3 different sources of water for 1 minute. But I have a condition. The rate of flow of the water is constant. So, but probably they are different sources, so we have different rates. What I did, I tried to open these 3 sources for 1 minute. And the amount of water that I put, I tried to see its level. I reach it to a certain level. Then I put similar thing. And I opened one by one. I opened the first source first for 1 minute. And then close it, the second source for 1 minute. Close it, the third source for 1 minute. My question right now, are you expecting the level of the water for these 2 different experiments is the same or different? If I open all of them at the same time and I open one by one, the same, right? This is superposition. Superposition is saying what? If I have different sources, like voltage source and current source, and what do you want? You would like to calculate the voltage across 8 ohms. What he is saying, you will apply the first voltage source that you have. And what about this? Remove it. And calculate VO due to 25 volts. And then remove 25 volts and apply 3 amps. This is the second source. And calculate VO due to 3 amps. And at the end, add the calculated VO due to 25 volts and the calculated VO due to 3 amps. This will be equal to VO as if you have those 2 at the same time and you solved the problem using these 2 sources. Are you seeing what I'm talking about, guys? So as if he is asking me to simplify the problem by solving it based only 1 source each time. So if I have 3 sources, I'm going to solve the problem 3 times. But instead of using the 3 sources, I'm going to use 1 each time. But I have to ask you a question right now. What is the meaning of removing voltage source? What is the meaning of removing current source? Removing voltage source means I I will substitute it by short circuits. Removing current source means I will substitute it by open circuit. This is very important. Again, removing voltage source means substitute it by short circuit. Because if I have short circuits here, the voltage is equal to 0 across that short circuit. Removing current source means substitute it by open circuit, because open circuit means current is equal to 0. Do you like me to repeat anything? Let us apply that here. Yes. Removing voltage source and current source, or from the beginning, the methods. Okay, removing voltage source means substitute it by short circuit. And removing current source means substitute it by open circuit. Let us apply that for this problem. So here, I'm going to apply 25 volts and remove 3 amps. But before I forgot, because he said here, a linear circuit excited by multiple sources will have response which is the sum of individual responses. What do you mean by linear circuit? You are talking about voltage or current. What about if I'm talking about power? Power is non-linear. Why? Because the power here is equal to I squared times R, or V squared over R, or I times V. So the power is not considered for this theory. What do you mean? I mean, if I apply 25 and I removed 3 amps and I calculated the power across 8, and I repeated the same story by applying 3 amps and removing 25, calculated the power across 8. If you added these two powers, it will not be equal to the power in 8 ohms due to these two sources. Because he said here, this method is applied only for linear, which means for voltage and current, not for power. I'll calculate the power and I'll show you. Let us see here, if I apply 25 and I removed 3 amps, the new circuit, this is my circuit that I have. What I would like to do, I would like to apply (25) and remove 3. So I'm going to erase this guy. I'm going to erase this guy, which is 3. And I will try to solve the problem based on that. Any question for that modification? Okay, what do you want to do? I would like to calculate VO prime. Why I'm calling it VO prime? Because it is not VO, it's part of VO. So I give it another name. I will calculate VO prime. How to calculate VO prime? Which method should you use? How to calculate VO prime? Mesh, I have 2 mesh. Summation of the voltage for each is equal to 0. I will solve these 2 equations and I will find my solution, yes. But at the end, I have 2 equations in 2 unknowns. Excuse me? Yes, I can use the current divider. But before using the current divider, I have to calculate R total. These 2 are connected in the overall with this n, the overall with 5n. Then I can calculate R total, and then 25 over R total will give me this current. Like what my friend said, if you would like to find the voltage here, you have to use the current divider for finding the current in this guy, which is equal to I total multiplied by 20 divided by 20 plus this resistor. Once you calculated the current in this guy, you can calculate the voltage. Another method. What else should I do for calculating VO? I can use node voltage methods. If you try to use node voltage method, we will say this guy will be my reference node. And then I'll say summation, the current for that node is equal to 0. So the current in this guy is V minus 25 over 5, V minus 0 over 20, V minus 0 over 12. If you calculated V, it will be straightforward and very easy to calculate the current in this guy, because the current in this branch is equal to V divided by 4 plus 8. Then you will be able to calculate VO prime. So based on that, I can solve the problem using any method you like. But you have to think, which one is more easier? Based on what you said, I think it is more easier to use one of two, node voltage method, or calculate R total and then by using the current divider calculate the current. But if you try to use mesh, you will have two different equations. But you can use if you want. But I'm trying to choose the easiest one to solve the problem. This lecture is very important because I'm showing you different ways of thinking for solving any problem. And this is what I need from you. I don't like you to copy and paste. I'd like you to understand. I'd like you to know how to think for solving the problem. This is very important. So if I decided to calculate R equivalent, I can say that R equivalent for this circuit is equal to those are connected in series in parallel with 20. So I can say 20 in parallel with 12, and the overall is in series with 5. So this guy will be equal to 20 times 12 over 20 plus 12 plus 5. If you try to calculate this guy, it is equal to 15 volts. Sorry, it is equal to 7.5 plus 5, which is equal to 12.5. Am I right? Am I right, guys? Now, I'll try to calculate the current here, which is I. So the current here, I, should be equal to 25 divided by 12.5 amps. Once you calculated the current, you can calculate the current in this guy, which is I1. So using current divider, I can say that I1 equals I multiplied by 20 divided by 20 plus 12. Once you calculated I1, you can say that VO prime is equal to 8 times I1. If you try to calculate this guy, I believe this guy will be equal to 10 volts. In my notes, I didn't follow that way. I tried to solve it in my notes using different way. What is that way? I tried to calculate the total resistance of 20 and 12. Then the overall of 20 and 12 is connected in series with 5. Yes. So the overall of all of those are connected in series with 5. So I have two series resistors, right? And I know the total voltage, which is 25. Can I find the voltage between these 2 points using the voltage divider? Yes. If you found the voltage between these 2 points, it is the voltage across this branch as well. You can use whichever method you like. Any method is okay once you are reaching to the right answer, since I didn't ask you to follow a specific method or way. Now, I'm going to repeat solving the problem again, and I will try to calculate VO due to 3 amps. So I'm going to put the circuit again. And what I'm going to do is I'm going to apply 3 amps and remove this guy. Removing this guy means what? Removing the voltage source means short or open circuit? Short circuit. So I will remove this guy and I will draw short circuit here. So apply 3 amps and remove 25 volts. Now, what do you want? I would like to calculate the current in this guy. How to calculate the current? Which method should I use? How to calculate the current in this guy? Which method should I use for calculating the current in this guy? What do you like? You can say the name of the method and I will let you know how to use it. I'm solving by using the superposition right now. Maybe you were sleeping and you woke up. So which method should I use? If you try to use node voltage method, you have these guys will be my reference and then I'll have only one node. Summation of the current for that node is equal to 0. I can find this voltage and then divide this voltage over this 12 ohm resistor to find the current here and then find the ohm. Or I can use mesh, but my friend here is saying the current divider, which is more easier one. Why? Because if you try to look to this circuit, those two are connected in what? In parallel, 5 and 20. So I can find the total of 5 and 20. So those are connected in parallel. And those are connected in series. And the overall is connected in, yes, the overall is connected in parallel. As if I have two branches connected in parallel, use the current divider for finding the current in each. But before doing that, I have to find the total of those. So 5 is in parallel with 20, which is equal to 20 times 5 over 20 plus 5. It is equal to 4 ohms. And 4 is in series with 8, which is equal to 12 ohms. I can right now say using current divider. Then based on that, I can find the current here, which is IO, which is equal to 3 multiplied by 4, which is this resistor divided by the summation of this and this one. So 4 plus 12, this guy will give you IO, which is equal to 0.75 amps. Once you calculated IO, I can calculate VO double prime, which is equal to 8 times IO. So this guy will be equal to 6 volt. Once you calculated VO, you can calculate VO double prime plus VO prime. It is equal to the total VO, which is 10 plus 6. So this guy will be equal to 16 volts. Now, if I asked you to calculate power in 8 ohms, you are going to say the power in 8 ohms is equal to V squared, which is 16 divided by 8. So if I asked you to calculate the power in 8 ohms, it is equal to VO squared divided by 8, which is 16 squared divided by 8. So this power should be equal to 32 watts. But please don't say the power in this resistor is equal to the power due to VO prime plus the power of VO double prime. Because if you're trying to do that, you will say 10 squared divided by 8 plus 6 square divided by 8. 10 square will give me 100. Plus 6 square will give me 36. Divided by 8, it will be something else. It will give you 17 instead of 32. Are you seeing what I'm talking about, guys? So I'm using this equation for calculating voltage and current, but for the power, no, at the end, calculate the power. I'll show you that. So I'm not allowed to say power in 8 ohms is equal to VO prime square over 8 plus VO prime double prime square over 8, because this will be, if you try to calculate it, it's equal to 17 watts, which is not the same like this. This is wrong. Why it is wrong? Because this method is used only for linear circuits. It's not used for calculating the power, but it is used for calculating the voltage and the current only. So, as a conclusion for what I said, so far we have learned many methods. KCL and KVL, one of them. Find R total and then find I and I total, and then start to distribute the current using current divider, or try to use the voltage divider if you know the voltage across 2 branches connected in series. And then we started talking about node voltage method and mesh current method and superposition and substitution theorem. So we covered many different ways for solving the problem. Which one should I use while I'm solving the problem? Next class, I'm going to talk about Thevenin and Norton and maximum power. So which one should I follow while I'm solving the problem? This will be our discussion. After covering all different methods, I'll sit with you and write one by one. When should I use that? When should I use that? And this will be open discussion between us to show you when should I use Thevenin, when should I use Norton, when should I use mesh. It's depending on the problem itself. But right now, I'd like you to understand how to use superposition, how to use source transformation, how to use node voltage methods. Okay, guys? Any question? I'll see you on Friday to talk about Thevenin and Norton. Thank you.